graybeard, been working on Linux machines since before I was born. The exit's at the rear. This talk is not for you. I have nothing to offer you. But for everybody that's trying to get into the industry, or maybe wants to see at least how I think the best way to do that is, then you're in the right place. So yeah, if you have several years in the industry, it's not for you. This is for students. This is for... Perfect, yeah. Teachers are welcome. Most important thing I can stress for teachers is that written tests are almost useless. So, you need a computer lab. Whether or not you know you need a computer lab, you need a computer lab. So, the best advice I can give when getting started in cyber is it's not sink or swim. Everyone has that one thing that they're really good at, and then a little bit of knowledge everywhere else. If someone comes up to you and says that they're master of everything, they're absolutely the best at every single part of cyber, they're wrong, or Google has released some new AI. So you have to be patient. You have to start small and work your way up. Nobody started knowing absolutely everything about whatever field they work in. So the next most common thing that people complain about, at least to me, I want to settle that debate here now, forever. Okay, this is not Windows versus Mac versus Linux. Everyone is going to tell you something different. Okay, in my experience, the best computer that you need to get started is the one that you already have. You do not need to go out and buy a new computer for learning cyber. I do not understand why people say, "Oh, well, I'd really like to get started in cyber, but I just need a better computer." If your computer has a web browser, that's like 99% of what you need. All right. Now, that being said, I do recommend if you are in the market for a computer, you probably want quad core, you probably want a little bit of RAM. That is specifically for virtualization. You do not have to do that. There are plenty of resources online where people will host whatever you need for you. That being said, we will get into that later. So, this is a little word cloud of all of the buzzwords that I usually encounter in marketing pitches, and it's scary. It's really difficult to see where should I get started, right? The biggest thing I can stress is you want to start small and you want to work your way up, right? But when you have all these crazy buzzwords being thrown around, how are you supposed to know which one to pick? How are you supposed to know where to get started? Right, and so that's sort of the meat and potatoes of the talk, is where do you take this apart? Where do you draw the line and say, all right, enough of the marketing terms, we're going to blockchain, the cloud, AI, to, give me money. Are you still paying attention? Okay, good. We're gonna try and cut through all that noise and come up with, a curriculum to get started. So, the absolute basics is how to computer. Like, if you are one of those people that need your grandson to help you check your email, you really have to handle that first. Once you've got a handle over how your computer functions, whether it's Mac, Linux, Windows, updates, patches, that kind of thing, how to just use your computer, have a general understanding of how that file system works, how that underlying mechanisms work, then you really want to learn into the OSI model. And I know everyone who has had a college computer science in here is rolling their eyes. Oh, great. We have to go through this again. I'm going to try and see, I know. There was a test question on it, wasn't there? Several, yeah. Please do not throw away sausage pizza, one of those. So once you get a handle of the OSI model and what it is, the OSI model is, in a sense, how things communicate in most models, right? So in order to kind of have a better understanding of that, I'm going to show it in a second. You really need to have a good handle on networking, at least like the very, very basic, oh, my computer can talk to this other thing, which is basically another computer, and then it talks to someone else. That's how I send an email, right? And then you sort of want to get into virtualization and learn how to simulate those environments. Once you get a little bit more advanced, have a nice, like, secure sandbox to sort of take stuff apart and work with. So here is the OSI model. I'm sure you've seen the slide before. I'm sorry. Any flashbacks, panic attacks, whatever. PTSD, triggers, whatever, trigger warning. This is the next 2 slides. The OSI model is really, you don't need to know every single layer exactly and how each port and protocol works. You don't need to know that. What you really need to know is a general understanding of, oh, this is where it turns into, this is where it goes from software to network, which is that heart of the OSI, the transport layer. This is where it leaves my computer in software, and then this is where it hits it in hardware. Most exploits, if you have some kind of exploit at the CTF, they're going to ask, well, what layer of exploit is it? Is this a network exploit? Is this a man in the middle? That's network too. Is this some kind of JavaScript-y type exploit, SQL injection type thing? Well, okay, that's definitely the software side of things. Or, is there a vulnerable package in whatever Linux server? Is there an outdated version of SSH or Telnet or something listening on a port? That's definitely hardware. And so you sort of want to get at least a general idea of where all of these exploits happen and why they're there and what everything is for, if that makes sense. Right. Any questions so far on the OSI model or the general idea of what I'm trying to get? So, TCP/IP model, it's more technical, and I feel like the OSI model gives a better overview of how things happen, right? So say I want to send like a Telegram message, or if I want to just send an IM from me to you. Okay, well, there's software that has that client, and that message is composed there. Then it's transported. That's the important part, is it's en route in the network, right? So that's where all your network attacks happen. And then it's on the server. It's being computed by the server. That message is then relayed to you, right? So I feel like the OSI model more directly maps to attack paths for exploits. That makes sense. At the very least, in this sort of 3-layer broken up segment of where does that exploit happen and why does it happen. Does that sort of answer your question? Anybody else? No takers? All right. Jeez, rough crowd. All right, so one of the biggest things that you need to know if you're getting into cyber is networks. Because literally everything is networked. Everything. Your phone, your computer, your email server, all of it's somewhere in the cloud, right? The cloud does not exist. The cloud is not real. It is a marketing ploy, right? All of it's just networks. All of it's just computers hooked up to those networks. They're all talking to each other. So you need to know what's an IP address, what's a MAC address, what's the difference. Why do I need to know the difference? What are they used for? Right? And so who wants to answer some of these questions? If no one volunteers, I will start picking random members of the audience. You look like you know the difference between a port and a protocol. Sitting right there in the front row. No? Shaking your head? No? No? Come on, tell me the difference between a port and a protocol. I'm going to keep picking on you until you answer the question. Wow. It's the only one I could give without being inappropriate. I'm pretty sure they're recording us. So if we're going to go over a quick networking in 5 minutes, IP addresses are going to be that software-defined address that's going to be designated by your network stack. Whenever you connect to the hotel Wi-Fi, which you should not do because it is awful in many, many ways, that network stack is going to give you an IP address more often than not. And if someone has a network that doesn't have a DHCP server on it and they tell you it's because of security, they're wrong. They don't know what they're doing. That MAC address is going to be your actual hardware address of the computer. That's not going to change. Yes, you can spoof it. We're not getting into that. It's fine. I get it. Ports and protocols. So there's a whole bunch of ports. All you need to know is that they're basically doors, right? You have to open a port for me to send traffic to it. You have to be listening on that port to accept that traffic. Protocols are, and I struggle to say this in a room full of people that are probably smarter than me, but protocols are basically useless. They're sort of community-defined standards of how that connection happens. And people like to conflate the two, right? So like, oh, port 22 is open. That means they're running SSH. No, that's not what that means. That means that port 22 is open. Most commonly, they're going to be running SSH, but there's nothing stopping you from running MongoDB listening on port 22. You can do whatever you want. I have a friend of mine that firmly believes that he needs to run SSH on the telnet port of every machine just to mess with people. I mean, look, it's just one of those things where if someone scanning your network sees port 23 and they start throwing telnet packets at it and telnet attacks at it, and that's the farthest they get, I'm fine with that. Because they clearly don't know what's going on. Well, you would think. I mean, most college freshmen probably don't know the difference. They're just going to see port 22 open and assume it's SSH. They're going to see port, 3389 for RDP? Jesus, there's so many RDP exploits, but we're not going to get into that. And then here's going back to what you were saying earlier, TCP, IP, UDP. Really what you need to know is most traffic you're going to look at is TCP. Like 99% of it. If it's UDP, then they're doing something odd, or it's either a video game or Netflix, probably. That's pretty much all you need to know about that. Whenever you have a TCP connection, there's an actual connection that is established. There's a three-way handshake that goes on. Certificates are exchanged if they're doing security. And that session is what you're going to be looking at in Wireshark. For UDP, they're just going to kind of throw packets at you and hope that they get there, maybe in the right order. Who knows? But for security purposes, I wouldn't worry about it too much. It's just a whole rabbit hole that you can go down, and it's not what you're going to see in the field, like, most of the time. And so here we get into my actual expertise. The part of the talk that you have been waiting for, probably, is, so a little bit of background about me. I built cyber ranges. I built virtual cyber ranges for the National Guard. So I stood up and fully populated Class A networks full of vulnerable machines, wrote curriculum to exploit them, documented all of that, packaged it up for the National Guard to use for their cyber training exercises. All right? And so this is where I believe most of your learning is going to come in. And what I mean by that is if you have a computer and you understand virtualization in any effect, even if you're just running VirtualBox, even if you just know Docker, the amount of things that you can do and the sheer volume of things that you can learn with that technology at your fingers far outstrips what you would get from reading a textbook, following a blog post, looking at Reddit, right? I feel like hands-on experience is the most important thing whenever you're learning cyber, and virtualization is how you're going to be able to do that. Because not everybody's going to be able to stand up 10 different computers, hook them up to a physical switch, and then start sending traffic back and forth and try to virtualize a really small office network. And if you do virtualization right, even on that little razor blade there in the back, I see you. Yeah. Even on your little Ultrabook, you can run, probably 50 VMs and be fine? Yeah. So, virtualization is probably one of the more complex things, but I think that's a good place to start because it will, again, let you learn a whole bunch more. So let's get into that a little bit. So you're mainly going to have two kinds of hypervisors whenever somebody's talking about a hypervisor, right? And most often, somebody's going to say, oh, just spin up a VM, right? Well, that's going to be your layer 3 on top of the operating system. That's going to be your VirtualBox. That's going to be your VMware Fusion or Player, whatever you're on, whatever version you're on. And it's going to be really slow. And it's going to be slow because it has to virtualize an entire kernel for an operating system on top of the kernel that you are already running. Right? And for every VM, you have to virtualize that individual kernel. So if I spin up 10 computers with a standard type, 3? Standard type 3 hypervisor, then I'm actually running 11 computers. That's why right in the very beginning when I said, what kind of computer do you need? You don't. But if you have a quad core and you have a little bit of RAM, you can run more than just a couple VMs, and you can really build it out. You don't need it. There are better ways to do it. But that's what I would recommend just for getting started. There's pros and cons of running different kinds of VMs. So if you have like an old dedicated computer and you slap ESX on it, that's probably going to be one of the biggest learning experiences for you. So that's going to be a type 2 hypervisor. That's going to be on metal. That's dedicated hardware that is designed to just run your virtual machines, to just run your lab at your house, right? And that's where you're going to get the most volume per performance, if that makes any sense. So like if you just have a regular laptop and you're running Windows 10, whatever patch version it's on, you can spin up a couple of VMs and you can do fine. If you have that same computer running an ESX cluster, you can spin up way more. You can really expand your scope, and that's not going to be the first step. And I can already see people going, oh, ESX, I got to write that down. I got to spin up ESX whenever I get back. No, that's not what you need to do. And then the last part is containers. And I don't know if you can actually see that because the resolution is really small, but it says, shut up, I know it's not actually a hypervisor. So container, we talked about how whenever you virtualize a computer, you're going to have a separate kernel for every machine that you spin up, right? Well, if you run containers and they have compatible kernel types, you share that kernel between all of them. That means that instead of running 2 or 3 or 4 VMs on your laptop, you can spin up maybe 50 containers all at the same time. And not only that, containers are way easier to stand up. They're easier to manage. I can see that smirk. I will stop for questions here in a second. But they are lighter weight. They are easier to spin up and down. And they are very useful when they're already made for you. So I'm going to pause for questions, so you raise your hand. So a container is similar to a VM, except it shares the kernel. So here is a diagram of traditional virtual machines versus a container engine. So instead of virtualizing each individual operating system that you want to run, right? So say you're on a Windows laptop and you want an Ubuntu VM, right, to actually work with, Linux commands and stuff. You have to virtualize that entire thing. if you're running a container and it's got a compatible kernel, all you have to do is run that container engine, which is just a daemon. It's just a program. And you don't have to virtualize the kernel for every machine that you run, which means that you can spin up a whole lot more. They're a whole lot lighter, and it's super, super easy. Any more questions concerning containers, VMs? What's up?
So container would be like the new Linux on Windows that you're using that for. Would that be correct?
No. So what they're doing now is really weird, and it's some kind of hybrid BS virtualization. I believe the actual, you're talking about Windows subsystem on Linux, right? Or Linux subsystem for Windows? Yeah. So I believe the way that they're actually implementing that is by using Hyper-V and having a Ubuntu VM in the background that you're not allowed to touch, and then just piping your commands through that, and then doing some kind of voodoo magic to make it work. But I don't know if you saw that it was announced that the next major version of Windows is going to ship with a Linux kernel. So it's going to ship with the Linux kernel, and they're open sourcing all of .NET. So Windows is... Man, I have hated Microsoft for such a long time, but it's really hard to hate what they're doing here. So do we have any more questions about VMs or containers or... Yeah, what's up? Pros and cons? Why would you use one over the other? So containers abstract away a lot of stuff. They do containers... For example, it's really hard if you're going to do memory forensics. What you can do is you can spin up a virtual machine and open a web browser, let's say, and log into your email. And when you log into your email, that login is stored in memory somewhere. Whether or not it's encrypted, how it's handled, how that implementation happens, it's still in memory. So if you pause the virtual machine, then it goes into like a suspended state, so you can go right back to where you started from, right back where you left off. And that's actually a memory dump. So one reason to use virtual machines over Docker containers is you can just get memory dumps from them really easy, and then just take them apart and with volatility or something and do memory forensics on that. That's one pro over the con. Also, VMs, I don't know if there is a way to hook up the GUI to a Docker engine. I think someone tried to do some research on that, but Docker containers usually don't have a front end. So, like, Kali, let's say. Everybody here knows what Kali Linux is, right? And if you don't, it's a penetration testing Linux framework distro that gets packaged and shipped out, right? I would definitely say run Kali in a VM. It's got a GUI, it's there for a reason. Some things are buggy, some things are broken, but some people just need a GUI for stuff, and that's okay. I would definitely say run that in a virtual machine. If you want to spin up something lightweight that has network, that has some kind of vulnerability there, you want a container. If all you're doing is, I want to hit this host on a network, and I want it to respond in a certain way, you want a container, probably. But if you want to use the machine, you probably want a VM, if that makes any sense. Containers are like apps, kind of, but packaged with the operating system. So one reason why people really like Docker is, oh, well, it'll handle all of my dependencies, and it will compile and build the code exactly the same way every time. So they use it for development, they use it for DevOps, they use it for rapid deployment, stuff like that. But it's basically just application-focused instead of full big-picture OS-focused. So it does a lot of abstractions away from like the file system, stuff like that. What? Docker is probably the most popular container engine right now. It's free, it's open source. I will go over a Docker container specifically for like looking at cyber stuff to show you some of the pros and cons later. Exactly. Yes. That is actually right there in my presentation, spinning up a website and with a Docker container and then coming back in there. Yeah, that's exactly the use case that you would want. And that's why I think learning about Docker and learning about virtualization is really important, especially since when you learn how to exploit stuff, when you're just starting out and you're just throwing payloads all over the place and you're not really sure exactly how everything works, but you just want to do it, you're going to make a lot of mistakes. You're going to mess stuff up, right? And if you spent, 3 or 4 hours building this full lamp stack from scratch in a VM and you're testing against that and you break something, you got to figure out how to unbreak it. In a Docker container, if you break something and you can't figure out what you did to it, you just destroy it and press the button again and it comes right back up exactly how it was before. It's great. Can't tell you how many hours I've wasted rebuilding VMs for that range. Any other questions, concerns, comments? I want to be as interactive as possible. I'm not just going to sit up here and preach at you. All right, cool. So again, we're in containers. Yes, it is that easy. You can spin up machines, play with them. One line. There is a full website called Docker Hub where people store all of their containers. And this is where the next example I'm going to show you is. So for those of you that don't know, this is DVWA. It's probably one of the more popular web testing frameworks. And this website that you spin up is basically just like web testing 101. Right? Once you log in, it's got a bunch of tabs, and you go over SQL injection and command injection and cross-site scripting and stuff like that. And I don't know if you can see that there at the top right here. That is one line of code that was stolen directly from the Docker Hub website. I didn't have to write any code. I didn't have to do anything special. All I did was type in docker run. Well, I'll actually break the command down. It's docker run -- remove rm. So that'll delete it after it's done, so it doesn't waste any space on your machine or anything. You just spin it up and blow it away as you want. The IT flag is interactive, so that's going to let you see on the back end what all of the things you're doing are, like what's going on as far as, things being entered into the database and what processes are running, stuff like that. Port, you can change what port you want it to be on. This will just spin it up on 80 for you. And then the actual path for it. So the actual image that it's pulling is vulnerabilities/web-dvwa. One line of code, you can spin it up right now, and it'll pull this website up for you. If you look at the DVWA install guide for installing it on Linux, it's not one line of code. I want to see a show of hands. Who has actually installed this application? No, DVWA. It's a pain. Yeah? How long did it take you? A few hours, yeah. Yeah, that's about my experience with that too. Yeah. So once you've kind of flushed out, all right, I want to run Kali in a VM, and I want to hook up my Docker containers to run these vulnerable web apps, whether it's DVWA or Metasploitable or whatever application, WebGoat, whatever you want to learn on that particular day. Then you get in, once you feel comfortable with that, you get into the next step. What do you want to specialize in? Right? And this is by far the most simplified, boiled down explanation that I could possibly think of for red and blue. And it's much more nuanced, and there's a bunch of differences, but, and in all, the best red teamers are the ones that used to be blue teamers. And the best blue teamers, they're the ex-red team guys. So you need both. You just need to pick where you start. Right? Because if I spent 2 or 3 years with all I did was SQL injection. right? I know every part of that attack. I know exactly how it works. I know exactly what needs to be there in order for it to work. Now I know how to stop that from happening. Does that make sense? It's like, if you took apart your toys when you were a kid just to try and figure out how it works, and you got really good at breaking them, but then you had to figure out how that goes back together. This is sort of the same concept. So if you want to get into blue teaming, there's a whole lot more to blue teaming than there is to red teaming. And I know some red team guys are going to get mad at me for saying this, but the analogy that I like to use is, imagine that you have like a large balloon full of water, right? And your job is to keep the water in that balloon, okay? So you're patching it with tape, you're plugging holes with your fingers. Red team's going to come up with a shotgun, and they're just going to throw whatever at it that they can. They're going to throw absolutely everything, including the kitchen sink, at that balloon, and they're going to try and get as much of that water out as possible. And if something doesn't poke a hole, that's fine. They're just going to move right on to the next thing, right? Red team, their job is to drill down all the way down to the bedrock and figure out, did you do a good job securing this? So, at least with my experience in live red versus blue scenarios, is if we didn't have time to harden beforehand, we're going to be putting out fires for the rest of this drill. We're going to be closing ports, we're going to be looking at logs, and the time it takes us to actually do incident response, to take the machine down, get a system dump, do forensics, get a memory dump, look at the memory space to see what's going on, look if there were hooked processes, where did they get in, build the attack chain. The time it takes us to do one incident for that, red team's already done. They've finished, right? So, this is why network is so important, I think. I think network is probably the most important thing that you can learn whenever you're getting into cyber, because I'm going to go out on a limb and say almost every single exploit that was delivered in recent memory, it was through the internet, right? Like, how many news stories do you see of Facebook data breach, someone Mission Impossible through a freaking ceiling vent and plugged a flash drive into the server farm? Doesn't happen, right? It just doesn't happen. Almost every exploit is going to be network facing. And so if you don't understand how networks work, and you're trying to go do incident response, you're trying to go figure out, okay, where was the attack path? How did they get in? How do I fix that? And you don't understand like the basic connectivity part of it, you will not make any headway. And that's why virtual networking is so important too. Whenever you start building networks, whenever you start virtualizing your switch and your router and then hooking that back up to a gateway and then hooking up different machines to that, and then, okay, maybe I want another router with a different subnet, and that's going to come out through that same pipe, and okay, I'm going to trunk these ports together. That's really important to understand. So, this is supposed to be a shout out for Raymond, who usually runs the CTF, who encouraged me to give this talk and did not show up to the con this year. But if you were here last year or years previously and you've ever done his CTF, there is always a flag somewhere that says Recon is important. Because it is, right? The absolute most important thing whenever you're going into any engagement is visibility. Whether I'm red team attacking or blue team defending, whether I'm the first step in every attack is to run some scans. Always. Recon is the most important thing that happens in any cyber engagement, because you need to know what's there. You need to know how many machines are present. You need to know what ports are open. You need to know what's listening to what. If you haven't done some scans, if the first command you don't run is nmap, you're gonna have a bad time. Because you're not gonna know what's going on. You're not gonna know what address space you're in. You're not gonna know what VLAN you're tagged with. You're not gonna know anything. You're just gonna get dropped in and start typing commands. It doesn't make any sense. So, there are way more tools than what's up there. But in most cases, if you're going into a CTF or something, the absolute first thing you want to do is you want to figure out what your IP address space is, and you want to run some nmap scans. You want to see what's in there next to you. Once you get some machines, then you want to start running some vulnerability assessment. You want to run some vulnerability scans, see what's going on next to you, right? It's not enough to know, oh, there's 4 or 5 other computers in my subnet. No, what are they there for? Why do they exist, right? From an attacking standpoint, I want to maximize that attack surface. I want to know exactly every machine, what it's hooked up to, whether or not it's hooked up to 2 separate networks, because computers can have multiple NICs. People can pivot through things, right? So if you're red teaming, you want to know everything that's going on. You want to have a full idea of what's networked to what's vulnerable, what can I exploit, what can I not, what should I avoid, right? Okay, so now flip the table. Now let's say we're doing blue team. Can I get a quick show of hands here who's actually done real blue team before? Okay. Perfect. So I'm going to give you a quick little scenario here. Say that you just got hired. You come in, your job is to secure the network, right? What is the first thing you do? Inventory, right. So let's say that first thing you come in, you see a Class A network, and you have, 100,000 machines up. Next step. What's running? First part in my mind is, why is this a Class A network? Why are there so many machines? What's going on? Why do you need this, right? Empty space is a bad thing. Whenever you have a network, you want that network to be well managed. You want to know almost immediately where everything is. That's why separate subnets exist. That's why separate address spaces exist. You want to be able to look at an IP address very quickly and see, oh, that's one of our production servers. Why is that talking to the guest Wi-Fi? Shouldn't be. Ever. Free tip. Your guest Wi-Fi should never, ever, ever be allowed to talk to anything on your network. Ever. Right? And so once you start getting a little bit more familiar with that, once you start getting into the real arcane space, then you probably want to start getting involved in reverse engineering and developing a payload. And I know that some of you might want to jump right into RE, and for those people, I commend you. And that's probably what it'll say on your tombstone, because it is probably one of the hardest things that you can do in space. Reverse engineer, raise your hand if you can read assembly code. Great, so there's 4 people in this room that can read assembly. It's low level, it's hard, it's nitty, it's gritty, right? If you write a quick Python script, and let's say it's got a while loop, do while loop in it. You have any idea how many lines of assembly code that is? That's hundreds of lines of assembly to do a loop. So when you get into reverse engineering, specifically reverse engineering malware, the author doesn't want you to know what it's doing. What the author is doing is not documented. When you start reverse engineering malware, there is a section in the Intel developer manual labeled magic. I'm not kidding. I wish I was, but it gets into the real nitty-gritty parts. And so don't get discouraged, but it's probably one of the hardest things that you'll ever do. That being said, whenever you can finally take apart a virus and see how it works, and it's just one of the best feelings in the world. Whenever you finally crack it open, whenever you finally figure out what's going on. And then, conversely, whenever you develop your first payload, whenever you write your first virus, whenever you are fully capable of understanding every line of code that you just wrote and understanding exactly what your code is doing to that system and why it's doing what it's doing, and the fact that you just beat whoever wrote it. That's probably one of the best feelings you'll ever have in cyber. So if you can get to that level, you've made it. You should be giving this talk. But up until till then, key takeaways, right? If you sat through this whole talk and learned nothing but what I'm about to tell you right now, the most important thing you need is to not give up. Don't drown yourself in the sheer amount of content. There's so much to learn in the space. Pick something you're interested in and just go with it. That's got to be your first step, right? I recommend that first step is networking, because everything is networked and it's super duper important. But if the first thing you want to do is SQL injection, do that. If you're interested in it, if you know that you want to sit down and you want to drill down, you want to hammer out, how does this work? Do that. Next most important thing, Recon, inventory. What is going on? Where am I? Why are there so many machines? Why can the guest Wi-Fi talk to these servers and it's not supposed to? What connection was made 6 hours ago whenever we were compromised? Right? Logging is important too. If you don't have logs in your network, you're not going to know what happened. Your stuff's just going to crash, right? And you just gave away the win to the red team if you don't have any incident response in place. So you sort of want to be able to follow that attack path. You want to be able to know what layer that exploit happened at. You want to know when it happened. And most importantly, you want to have fun with it. Any questions, concerns, comments? I will start randomly selecting people for questions. How did I get started? So I was an intern in high school at Digital Forensic Solutions. It's a local company here in New Orleans. They got me interested in penetration testing and incident response forensics. Then I went to school at LSU for computer science. I started coding. I took all of our cybersecurity classes, and by all, I mean all 4 of them. Thank you. It was genuinely hard. Then I went back, did an internship again with Digital Security Associates, I think is what they're called now. It's the pen testing part of that DFS stuff, and helped set up a conference. And they brought me here, actually, 2-3 years ago. They brought me to my first NolaCon. I jumped into a CTF, and I totally drowned in it. There was so much content. There was so much stuff that I didn't know, and I totally freaked out. But we had a couple of interns. We banded together. We all picked a category, and we went with it. And the best learning experience that I got out of that is, hey, these guys are professional pen testers. They work for actual real companies. And they're behind us. Maybe we can do this too. Right? The amount of time that you put in is probably the most important stat. If you had a stat sheet write-up of what is important in cybersecurity, how much time have you spent in networking? How much time have you spent at the terminal? How many Linux commands do you know, right? All of that goes out the window. It's just how much effort have you put in? How much time have you put in? Anybody can get started in cyber, but the most common mistake that I see in students especially is they'll go back to this great big word cloud of big, scary, buzzwordy, corporate type terms, and they get overloaded, and they're like, oh my god, I could never do this. There's so much to learn. There's so much I have no idea what's going on, right? When you first get started, you're not going to know everything on that list. You're just not. It's okay. You don't have to know everything all at once. Just pick something that you're interested in and stick with it. Anybody else? For what? So setting up Docker, you would want to go to the Docker website. They've got a install guide. I believe it's just docker.com. But if it's I think it's in most repositories now. Pretty sure you can just apt-get install Docker and then go to Docker Hub, and there's going to be a Docker run command. And I will stay after the talk and actually show people how to set it up and how to use it and everything. Anybody's interested in that. Anybody else? What's up? That's the end. So the last slide is supposed to be a GitHub link with a whole ton of resources on it, but it's not. So I will make sure that's published with the talk or something. It's github.com/millsapcyber/breakingintocyber hyphenated. But there's a whole bunch of resources that I've compiled there for people to get started in a whole grand variety of different concentrations. Anyone else?
So you can pipe X11 through to a container.
You can.
Yes, it takes some fiddling, but you can do it.
Take some fiddling.
Not Wayland, just X.
Just X11. Okay, so it is possible. I would not recommend it. All right, anybody else? No? Are we good? All right, so that's the talk. You've got 10 minutes until the next one at 5. I guess I will hang around if anyone has any more pressing concerns about building cyber ranges or exploits or anything in general, I guess.